Imagine two observers, one seated in the center of a speeding train car, and another standing on the platform as the train races by. As the center of the car passes the observer on the platform, he sees two bolts of lightning strike the car, one on the front and one on the rear. The flashes of light from each strike reach him at the same time, so he concludes that the bolts were simultaneous, since he knows that the light from both strikes traveled the same distance to his eyes at the same speed, the speed of light. He also predicts that his friend on the train will notice the front strike before the rear strike, because from his perspective on the platform, the train is moving to meet the flash at the front and moving away from the flash at the rear. But what does the passenger see? As her friend on the platform predicted, the passenger does notice the flash from the front before the flash from the rear, but her conclusion is very different. As Einstein showed, the speed of the flashes as measured in the reference frame of the train must also be the speed of light. So, because each light pulse travels the same distance from each end of the train to the passenger, she can only conclude one thing. If she sees the front strike first, it actually happened first. Whose interpretation is correct? The observer on the platform, who claims that the strikes happened simultaneously, or the observer on the train, who claims that the front strike happened before the rear strike? Einstein tells us that both are correct, within their own frame of reference. This is a fundamental result of special relativity. From different reference frames, there can never be agreement on the simultaneity of events.